From the beautiful South Studios of Way Happy, this is Mr. Meyer and 14B, the intermediate value theorem, or what we like to call the IVT. It's something we're going to need to use later, or refer to at least to later. And so we want to make sure we've talked about it and know what it is. Now, here it is. Theorem 113, right? If f is continuous on the closed interval of a to b, and f of a is not equal to f of b, and k is any number between fa and fb, then there exists at least one number c in the interval a to b such that f of c is equal to k. There you go. That's it. All right? Done. All right, maybe we need to talk about it a little more. First off, what you want to know is this theorem just is what's called an existence theorem. It means that there is, all that is that something exists. It doesn't actually tell you how to find the answers. So it's just saying, hey, there's something that exists. Now, what does it actually say? It says this. First off, let's break it down. In example 1 here, you say, what are the necessary requirements in order to apply this theorem? Well, it's right there in the beginning. If C is continuous over the closed interval, A to B. So you need a continuous function. So what's the necessary requirement? Continuous over A to B, right? And that's a closed interval, including A and B. Then you have this number K. And what axis is K on? Well, look, it's K is any number between f of A and f of B. Those are the y values at A and the y value at B. So it's on the y-axis. So it is on the y-axis. Then there exists at least one number C that is in between A and B. So that means that there's some number C that's between the axes A and B. So that means the C value is on the x-axis. That's all it's saying. And then it says that now f of C is going to be equal to K. Now, again, what does that mean? Let's try to do a picture here in example 2. So consider the function at the right. I drew it in and I actually left a lot of the answer there, but oh well. So first thing you want to look at is my graph, just generic graph, nothing labeled, right? Just some points. And it's first thing you want to know is it continuous from A to B, right? So here's A, here's B, and our question is, does the graph look continuous from that interval? And I would say yes, right? That definitely looks continuous, no holes, no jumps, no asymptotes, nothing. So I'm going to say yes. And then it's going to say there's a K value then. There's some K value that's between those two Y values, the beginning Y value that you would get and the ending Y value. K has got to be somewhere between those two, right? So yes, K is between them. Yep. And then this example, how many C's are there that make it true? And that's the part I wish I wouldn't have labeled. I wish I would have made you guys go through and go, well, here's K, and it hits here and here and here. So there are 3 C's, right? 3 X values that would give us that K value. All right. And then I would label those C values. I would come down and I'd say, all right, this is C1 and this is C2 and this is C3. But that's all this theorem says is there are some C's that exist between A and B if K is between f of A and f of B. That's all it says. And of course, it has to be continuous over the closed interval. So you say, wow, yeah, that seems kind of obvious, but it maybe not. And so that's a theorem that we have to be able to use later on when we're trying to find some stuff. So that's the theorem. Now let me show you a real generic, easy way to try to apply this theorem. Here is one right here. Use the intermediate value theorem to show that for that polynomial, there is a 0 between the intervals 0 to 1, right? So what does that mean? That means, all right, I got this function that's definitely continuous over that interval, so I'm feeling pretty good. Step 1, check. Is K between f of A and f of B? Well, I got to find out. What is f of 0? So if I plug in 0, I get -1. What is f of 1, the other part of the closed interval? If I plug that in, I get 1 plus 2 is 3 minus 1 is 2. So the y values, so what we have here is the y values. I should have left myself a little more room. If you go from 0 to 1, that's your A and your B, and our y values go from -1 to 2, right? So when it was 0, it was here, and when it was at 1, it's there. Now, is our k value between that? Heck yeah, k is right here, right? K is at 0. So it's saying, all right, if that's true, then there must be some c value, or maybe multiple c values, that exist in order for k, there must be some c value where k is 0. And you go, yeah, that has to, because in order for the graph to get from here to here, in order to get there, it's got to cross. I don't know if it goes like this. I don't know what it does, right? But it's got to cross at least once, maybe more than once. And that's all this theorem says. So I would say, like since k is between RK, since 0 is between f of 0 and f of 1, there exists a c value such that f of c is equal to k, which is 0. That's it. That's the intermediate volume theorem, or the IVT. Have a great day. Stay happy, and I'll see you tomorrow.